In this chapter, we will talk about mechanical wave. The objectives are to define the wave, to distinguish between the types of mechanical wave, and to identify the characteristics of the wave. So what is a wave? The wave is a disturbance or vibration in a space. Again, waves transfer energy without transferring matter. The waves can be classified according to shape and according to nature. In this chapter, we will discuss the types of wave according to shape. So what are the types of mechanical wave? As it appears in this picture, there are two types of wave, transverse wave and longitudinal wave. Pay attention and look carefully to the picture to find the difference between the two types of this wave. The first type of wave is the longitudinal wave, where the particles of this wave propagate parallel to the direction of motion as appear in this slide and in the previous slide. The second type of wave is transverse wave. In this type, the particles of the wave propagate perpendicular to the direction of motion as it appears here. The direction of motion is to the right, while the direction of the wave is up and down, so it is perpendicular.
Application 1. Give one example of a transverse wave and one example of a longitudinal wave, being careful to note the relative directions of the disturbance and wave propagation in each. The solution is an example of a transverse wave, C wave, vibration of rope up and down. Another example about a longitudinal wave, ultrasound and ripple tank.
As we see in this picture, the maximum point of the wave is called the crest, and the minimum point of the wave is called the trough. Now we will talk about the characteristics of the wave.
The first character is amplitude. Xm is the maximum displacement of the wave. It measured in meter as an SI unit. The amplitude is the maximum displacement of the wave. It measured in meters. The second character is the wavelength between two brackets lambda. The wavelength is the distance needed to complete one cycle or oscillation. It can be measured between two adjacent crests or two adjacent troughs. Third character is period, symbolized by capital T. Period is the time needed to complete one cycle or oscillation. It measured in seconds. The fourth character is the frequency, symbolized by capital F, measured in hertz. Frequency is the number of wave cycles or oscillations per unit time. That means F equal 1 over T. So F equal 1 over period T. F measured in hertz, and the T is the time needed to complete one cycle measured in seconds. Another application about the characteristics of the wave. If you were to shake the end of a tooth spring up and down 10 times a second, what would be the frequency and the period of the sinusoidal wave produced on the spring? So we need in this application to count the frequency and to evaluate the period of the wave.
According to the definition of a frequency, which is the number of cycles in 1 second, in the application we have 10 cycles in 1 second, so f equals 10 hertz. While the period is 1 over f, so it's 1 over 10 equals 0.1 second. The last but not least characteristics is the speed, v. In general, the speed is the proportion or the ratio of distance by time or duration. In the case of wave, the distance covered in one cycle is wavelength, and 1 over t, 1 over period, is a frequency, so we can say that the speed equal the wavelength times the frequency, or v equal lambda.
Application number 3. Let's observe the following transverse wave and answer the following question. One, indicate the amplitude of this wave. 2. Find the number of cycles n in this wave in 0.8 seconds, or how many cycles representing in this wave. 3. Calculate the period t of this wave and deduce its frequency f. 4. Knowing that the speed of this wave v is 50 meters per second, calculate the time t needed for this wave to cover a distance d of 325 meters.
According to the wavefront in the previous slides, the maximum amplitude or maximum displacement is called amplitude, is 10 centimeter. The number of cycles covered is in 0.8 second, so n equal 2 cycles. Period is the time needed to complete one cycle, so it is 0.8 over 2, 0.4 second. Then the frequency is simply 1 over t, 1 over 0.4, it will be 2.5 hertz. And finally, we have the velocity and or speed and the distance covered, so the time will be d over v, it will be 6.5 seconds.
Yeah.